morning, Steve.
Hey, Lynn, how are you?
I'm all right.
All right, it's a little after 11, so we're going to get started. Welcome. When we put this review set out for everybody to take a look at, there were a lot of comments, and we felt the best way was to just have a little conversation and address the comments verbally, rather than, you know, try to update the shop drawings in some way that you guys might catch what we were doing. So we're just going to walk through the set and kind of go through the comments that are here, and then we can cover anything else that might be of interest as we go through. The team, you know, is made up of Tom and myself, and mostly the Jumpstart group. And Ray's been helping us with a bunch of things too. So some of the questions will probably fall to the Jumpstart group to give you answers, and we'll kind of roll through those as we go. And I'll just kind of take them in the order they come on the set. So the first question was, are we going to get extruder feedback on the new dies and assembly? And the answer to that is yes. The first round was going to be an internal round for all of you. And then it would help us understand if there were things that weren't clear, or maybe things that needed more explanation. Then the second round, we could make the drawings a little clearer, but based on what you guys had comments on. And that way we could go out to consultants and architects, contractors, our engineering groups, Larson and AWS, our vendors, and get feedback on the system from them. So first round internal, second round external, and then we want to sort of get a lot of feedback from everybody before we finalize the system. So. Should the part numbers be different than the W75? Probably. Haven't made that decision yet, but I agree. And the PUL parts are basically extrusions. Our game plan is to have those fabricated and furnished already fabricated. So we would not be fabricating the fiberglass parts. They would be bought prefabricated. So we would buy those with the metal, but we would buy them fabricated up front. So, and then doors, parapets, additional details. Yes, this was the base set of drawings, and we'll go a little deeper on the next set for sure.
So Steve, by fabricated, do you mean cut to size?
Cut to size and drilled. So
yeah, any notching, any holes,
and obviously cut the length. So it's just putting it on and screwing it, attaching it to the aluminum extrusion.
Yeah. So we wouldn't have to have special equipment, special respirators for people working around the fiberglass.
Okay, so just how that would tie into what the fab team's going to look like will be a consideration. Okay.
Yes. The PULX 01 and 02. So the question is, what is the solution for compromising different glass thicknesses? We'll talk about that in a minute. But essentially, we're changing the aluminum parts, not the PUL part. The drawings show a 1 1/4, but we can do a 1 inch if we just change the pressure bar and the face cap. So that's the game plan. And this question will be sort of developed as we go through the thermal testing. So we'll see what values it comes up with, and we can try a couple different things with that and see if it makes sense to do a PUL or if it would make sense to do something else. Okay, so this is one of the probably the more unique aspects of the system, and a lot of people had questions about it. So Laura drew a nice little installation instruction to kind of show what's really going on here. As you can see in this view, essentially we're straight cutting the heads, and then we're siliconing this little filler piece in between. And we've cut these legs down slightly to make a gap that we can seal to. But we've already tested this theory in the mock-up booth out back. We've already run seismic tests and everything else with it. It worked out really well. And the idea was to eliminate all that excess machining that was happening at this head condition by just using a straight cut piece between two other straight cut pieces. You can see that the lifting lug is quite different than it used to be because it's spanning across. It's not sitting on top of this piece. And then you've got two silicone sleeves, one in front and one in back. And then we're running this little gasket. This is the dart. I mean, this gasket runs through that gap. And then in the back, we have the little round gasket, and that's the plastic one, because we're going to run that through that gap also. The plastic one lets it give a little bit, so we were going to use the plastic one on the back side and run it through that gap also.
So Steve, I have a question. So then the lug slides on top of the silicone sleeve?
It slides up to. So it would sort of like be notched back. So the silicone sleeve would stop, and then this would sort of traverse over the top of it. We have some, there's some pictures of what we did in the mock-ups too that you could kind of see, but this is kind of what we did in the mock-up, so that's what we're trying to replicate here. So. Okay. Yeah, the head trim logic, definitely we can work that out to show what that looks like. It just wasn't super necessary for this first submittal. Yeah, the design will change the load transfer path at the stack joint if we're not using the bayonets. That's part of what we want to review with the engineers as we go out with the system for their review. We had heard that from them, but we didn't have anything specific yet. So. And then yes, this is silicone in place on top.
That's also bedded sealant. When you put silicone down and then bed that little piece in and then silicone sheet over the top.
Exactly.
And then is there a method to keep that aligned properly? Because it doesn't seem like the lug engages in that part.
Kendall, do you want to address that?
Yeah, that's correct. Yeah, the little dowel, the little 1/4 inch rod runs through there, keeps it in line. And at the top of the vertical, those front legs actually get notched down 1/4, so they bed that in sealant. And then as they're setting the chair down in, then you slide the rod through. So the plastic rod, not using the aluminum dowel, but the plastic one, will be engaged on the head on both sides as well as the bridge. And then the gasket gets run through as well in the front. And so we use the plastic dowel to give it a little bit of flexibility as the things are rocking and rolling. And we were pleasantly surprised with how it worked. So, I mean, during all the testing and everything. So the rod never actually broke. It just flexed in there and brought the bridge right back where it goes.
Okay.
So any of these dies with the chicken head, are they going to be new, or are we using existing? Because I'd have concerns with the tolerances if we're using existing and the rod falling out.
Most of these dies are new.
Most of the horizontal dies are new.
Okay.
You have a question, Lynn?
Yes, I do. Can you hear me clear?
Yes.
Okay. So I'm going to ask a question. I'm very picky. I'm sorry, but there's nothing personal. The reason I don't want input about this is that because I was the latest to join this team. I have to admit it. So I'm hesitating to input any comments. You know, I apologize what my attitude the last time when we have a meeting talking about this one. I just kind of denied that one right away. I did not give any input. I really apologize without explanation why I say that one. But here, because this is totally flipped my logical about the curtain wall design, because I used to be designing a different market of the facade systems, which is we always challenge for the watertight integrated systems. So my mind always drifting to another way. However, think about this one. I know this idea being marketed on a few years already, but we thought this will be failed. So, but I couldn't say that when the fail or successful is relevant. It's based on what you're talking about. They have relevant. So I shouldn't decline this one, but here's my questions, Kendall. So I'm not sure how deep you studied this. So by separate this one, I'm guessing you probably put a 1/4-inch gap for the silicone caulking, right? For the both sides of where you cut the pieces over there. Is that correct?
For the bridge,
1/4-inch
yes.
thickness. Okay. So that's a minimum required by down calling. If we don't do that, we couldn't get a warranty. Second, the silicone, once we have to think about the curtain wall system. It's a dynamic movement all the time. The lifespan they have to suspect to dynamic movement. The lifespan for the survival. I think our product lifespan typical probably 5 years, right? Because we have a 5 years warranty for our typical contract. So we're only responsible for the 5 years. So have you studied that one? The silicone bonding, how strong it is based on your, what am I gonna say? The bonding surface on each side, which means I'm saying is, let me explain me more clearly this time. So all this thickness over here, that's the silicone bonding surface we're talking about. We can easily calculate this one. By the thickness area of this one, how much bonding of the silicone we can gain from it, which is, you can calculate silicone can survival in certain seismic movement in the 5-year span. Does this can survival? Because the die thickness is important So without data, I cannot give you saying this is will be or will not. I don't know what to load your test over here. Have you sent this one to any down calling to approval? Are they gonna warranty this one for you? I don't know. So I couldn't give any comments about this one. This is why I totally stopped to do this. Anyway, that's all. I may be thinking too far, but I would say we are data-driven company. We should calculate this.
Okay, yeah, definitely, it's a good comment. That's what we're looking for as we go through this, so thank you.
Okay.
Okay, so for the other parts, as you saw, this is sort of the other big change that we're making, is we're separating the interior pieces and the exterior pieces with a piece of fiberglass. The part that's not as easy to see, oh, by the way, can everybody see my screen okay?
Yes.
Yeah.
Thank you.
Yeah.
I think
Yes.
everybody,
Yeah, I see it now.
okay.
I can now that you blew it up.
I agree.
Thank you
Zoom
for
it helps.
No, I can see it. Yeah.
What you can't really see very well is this setting block has a nub that tucks in this gap. So we're basically shoving that setting block in to keep this piece from rising up. We're also running some silicone in that area as we set that block. So that wasn't very clear, I think, and a lot of people didn't know what we were doing there. So that's how that keeps this from lifting, is that setting block. But this piece allows us to do silicone on all 4 sides of the glass, which gives us a better water tightness in terms of the system. It's kind of what Seattle's been doing for a while. And then these plate and face caps on the outside are not, they won't have weep holes. The water is coming off the ends, much like it does with our typical horizontal now. So there won't be weep holes in these locations. Kendall, do you want to talk to the trim lip and dust?
Yeah, so working with Bob Vaughn, we came up with the new trim lip design that eliminates that effectively, gets us a good tight seal. So all gaskets will be getting that trim lip. Cool. It's not really the trim lip, it's the lip that goes up on the glass. Yeah, it has an extra little lip there that sets that in. So we got the gasket sample from Trelleborg. The shop has built us a unit, and we tested it and did our little paper thing, and it looked good.
How'd you guys test it? Like a bunch of drywall dust, throw it on there? And...
Well, no. So Mike, we could go out to the shop and we could walk up to units and we could slide a business card between the glass and the gasket on units on the line. I didn't need to see drywall. We could tell.
Okay.
You could walk out. So with the new gasket, we tried it, and so it's just a longer trim lip, right? That just doesn't pull back away from it, right? So I mean, yeah, if you get out there and you push on the glass, you might get it to bend a little bit, right? But we think we've effectively got it solved. That now with that new lip, I'm not able to slide even thinner than a business card between the glass and the lip.
Cool.
Yeah, Mike, I mean, we tried to address that problem of getting that dust and dirt in there. I know obviously we've had a ton of problems with it, and it's super painful to try and clean out. So we've tried to address that. Obviously, as we do full-size units and test it, we can play with that a little bit more. Obviously, you volunteered to take some drywall dust and see if you could get it in there. So we have a volunteer for that.
Can I? Sorry. So I believe we have some shop people over here. I want to know the procedure, how we pump the silicone over there. Did you put a glass on top of the frame, use a glass weight to push the gasket down to keep the silicone leaking? Are you doing that?
Yeah, they set the glass on top of the gaskets when they're in the other position. Yes.
Okay.
We clamp the glass down with a clamp, with a quick rip.
Sorry, can you say one more time? I couldn't.
We add a clamp. We clamp the glass down to the frame on four on the
Why
fourth.
you need to add a clamp? The glass is the weight. It should be enough, unless you flip it upside down.
Yeah, you just don't want it slipping around when you go to shoot it. You're putting a lot of pressure on that gasket and shooting that caulking. You could push the glass around. That's what we found. So they use a clamp.
So,
but the question you were having was, and we checked this. This is 1/4 of an inch of silicone after the weight and the clamps and everything. So I had Jose check it.
Yeah, I was participating in the system design group. I know they have some fail because the gas gets leaking dust inside over there, which is cause the problems. You know, I'm not worried about the dust. It looks bad, looks worse. But the worst is I'm worried about the moisture leaking behind the gasket. That's a bad. By the time it could cause the deteriorate. You don't want that happen, for sure. So to solve this one, what I'm thinking, when you're doing the gasket design, are we doing the gasket design? Or somebody else?
These are designed
by. When you're doing this, I wonder, this is 85 diameter, correct? Or 75?
Yeah, these are designed.
I think this is 75, correct?
Yeah.
Because you want the, okay. So if you use 75, which is plus minus 5, which is normal one. But my point is, how you decide the holes in the middle is critical. Have you tested? Or someone, the supplier for the gasket, does it do the test? Because I used to be designing gasket for myself, so I'm guaranteed I never have that problem.
What hole are you talking about there, Leon? I can't see your figure.
Yes.
What hole?
Huh?
What
hole?
Oh, that hole there? That?
Yeah, there's a hole inside. Why you put, for example, over here, why you put 3 holes over there? And why you put that position? Why you have that size? How you decide it? Or you just swing the number by the experience? Or you calculate?
No, I had 2 holes at one time, and then the first design we did, we had 2 holes, and the trail board decided to add another hole. I think that was the recommendation from trail board.
Yeah, Efren, this is a big area just for gasket design. That's a whole big series over there. We can talk this one after this meeting. We can discuss. I'm very interested about talking about the gasket design.
How many holes do you want?
Design.
Would you like to put 2 holes, 1 hole, or?
It depends. I'm pretty sure we can calculate that one.
So it sounds like something
what's supposed to be.
Because we only have an hour.
That's what I'm. Yeah. Sorry.
No worries.
I know.
Okay. Most of the gaskets we work with Trelleborg on the design, they give us what they believe would work best. So a lot of the input we get is from our vendor, but we could take a look at that.
One thing I want to point out over here, silicone is very expensive, especially for injection molding or extrusion. When you're doing that one, the dye is very cheap, but the material is very expensive. The silicone can be more expensive than metal. This is the reason we want to put a hole over there. But the hole is tricky. You put too much, we cause defect over there.
Okay, makes sense. There was a question on glass thickness. The 1 1/4 is sort of, we're going to go either 1 or 1 1/4. That's our goal. So we don't have a lot of different overall insulated thicknesses. A lot of times when we need extra STC or other things like that, we go with something thicker. But if we can do it, we're hoping to use the Viracon VTS glass here, which would come with the argon fill and a warm edge spacer. And that spacer can be made in different thicknesses for the same price. So we're looking to, change the different makeups of the glass, but keep it at either 1 inch or 1 1/4 and not have a bunch of different glass thicknesses that we're using. That's the goal. Still working on that one. Let's see. We talked about that being plastic. We're missing a gasket. This is the gasket shape we're going with right now for Inviso. This is the gasket shape we're going with for Captured. So those are our preferred gasket shapes.
And that that rod is only plastic at the bridge. It'll still stay aluminum, I think, at the other. We can get into that if we want to just go to plastic everywhere. So.
But definitely plastic at the bridge. Right?
At the bridge for sure, yeah.
That may be something for Heather too. I mean, just if we redesign that or to take plastic better, would you have to use plastic everywhere, or could you use aluminum in some places, plastic in others? Good question.
I mean, I think we could do both, but we'd have to definitely redesign the plastic one to different size.
Okay.
If I miss things, you're gonna have to tell me because I'm trying to go through this on the fly. So this is not a Western part. This is actually a piece made by Trelleborg. So this will be almost like a hard gasket. So that's what this design is. We changed that around at the stack because we had some leak issues. I guess we haven't got to the stack yet, but we had some leak issues at that condition. So we'll talk about that here. So this part used to be sort of back in this area, and then you were kind of caulking over it, but that caulking was behind the weather line of the part. So we've moved this external to the weather line so that even if it were to leak, it doesn't get behind the seals at the head. So that's what this part is doing. So we've made that change because we had that problem on a number of jobs.
So Steve, I had my notes there just in relation to that little part is the dimension points.
Mm-hmm.
So it is sloping. And so now the dim point is to the face, which is lower than the body. And I don't know how that affects layout for fabrication and glass bites. Same with the gasket above the Inviso. You see the 1 inch is going to the bottom of the arbitrary point of this gasket.
Mm-hmm.
So that 9/16 is not really the size of the joint. And is that really the dimension points we want to be pulling? Because that little 16th or so is, you know, again, we're trying to get down to the 0.4 decimal points in Revit. That could hinder stuff. I just want to make sure that really what we wanted, those are the correct dim points we want to be using.
Okay, yeah, that's a good thing for us to look at as we move forward for sure.
Yeah, good point. Those are critical for doing fab layouts too.
Yeah, because the one on the Inviso gaskets, like our current details right now, they're to the face of that little gasket trim, and I'm not even sure that's accurate. So this one now is purposely looks like it's at the bottom of the gasket, which I'm not sure if that's correct, but just want to bring it up because it's stuff I'm checking. So just want to make sure it's right.
Oh, that's actually a great point. I love how deep in the weeds you guys get, you know, and totally serious. That's super cool just to have this multi-review and everybody's looking at kind of those different things. So very cool.
Yeah, there was a note about notching this piece as that vertical comes down. So we'll take a look at that. I know that's something that the takeoff group's running into now.
With the new bayonet though, you wouldn't need it, I think, right? Because the bayonet gets notched at the bottom, so it's only what's sticking up of the bayonet, I mean of the lifting lug would slide right in between the bayonet racer, right? So you wouldn't need that. That notch is technically for this right here, right? Since we're notching that around that area, it would clear it, right?
Yeah, from the other picture we were talking about. So we have to look at that. If it clears it, then we wouldn't need it. But if
yeah,
we would.
Yeah, looks good though.
Yeah. Good point. Thank you.
But can you go back to that the installation manual right there, Steve? Do we need a notch to clear that on the vertical to clear the the lug?
Depends on the height of this leg, right?
Yep. Mm-hmm. So we do need an extra notch on it though.
Yeah, so we need to look at that.
I think it's there, right? It's that 1 1/4.
Well, I think it needs to be taller than that, right?
Yeah, I think it needed taller than that because you had to, you know, thinking about the movement.
So that's a good one. Can you make a note for that one, Kendall?
Yep.
For us to look at. All right. So we've got, what does this hatching mean? Kendall, is that caulking that's back in there, or what is that there on the ends?
I think they're caulking at the end.
The
Maybe
bridge.
just using the wrong hatch there.
Yeah, the bridge at the end, right?
Yeah.
As it closes off the end there.
Yes.
Yeah, it looks like Kendall stepped away, but yeah, that should be the caulking at the ends.
Okay. Yeah, again, these are intended to be straight cut. And we'll have to work out all the actual part lengths and things like that as we go. And then the question was, how are we going up and over the chicken head on a soffit condition? Because we need 1 3/8 inches to get over. And we only have 1 3/8 inches at the top.
Yeah, those dimensions will get adjusted. Right now, that's why we didn't put any dimension there. It's just, but yes, we need a more clearance there to clear your chicken head there.
Yeah, I thought also, maybe I'm wrong, but I thought this piece is actually sitting on top of the head when you set it. So, right, I mean, so this would kind of get in the way too, right, that piece. You need the 1 3/8 inches.
If not a little bit more.
Yeah.
Yeah.
I think we're working on a sill detail for that, to strip down for that installation. It's something in our design system meetings we've been kind of looking at.
Yeah, those design came from Seattle.
So we would probably need to incorporate that into that sill at a soffit.
Yeah, we borrowed a number of the ideas from the Seattle group too. So some of these things are coming from there. So then some questions around this piece. Benetta, having this a 2-piece pocket delivers, this is a very expensive die. So having a snap-in piece means I can do different glass thicknesses when I need to. So that's why we would have that as a 2-piece.
Sorry, so I had one of my questions on that was, we had the note there to bed it in sealant because it's a perimeter, but then how do you bed it and then expect it to snap? And then it's going to be a continuous bed of sealant in a hollow? I just don't know, how does the shop do that? I mean, you got to put a whole bead of sealant on both raceways, squish it in and hope it snaps? Because then you're scraping away the sealant, or it's not going to really engage. I don't know if it's been tested, but it just seemed a little odd to bed a snap-in piece, and that's our perimeter seal, so it just made me a little nervous.
Mm-hmm.
And it's going to be a continuous for whatever the lengths of these units are. And that just seemed like a lot. But.
I think we were talking, Steve, right, about making that protrusion edge the water line, right? Caulking to that, not the aluminum.
Yeah, this would be a protrusion piece, right?
Correct.
But I think this part is said it's bedding and sealant, which would be like here and here, right?
Yeah, but I think if we move that that water line to that back there, then that wouldn't be an issue. That'd be on the exterior side.
Yeah, I agree. I think moving the water line back would make more sense.
Yeah, so we wouldn't have to worry about bedding that in sealant or anything like that.
Mm-hmm.
So the components of that, the channel shaped piece is the pultrusion, that's the fiberglass, and then the snap in piece is an aluminum extrusion. Is that correct?
That's
true.
I have a quick question on the glass. Are we not keeping the 1/2-inch bite anymore? On the captures, horizontal.
How'd you get this? Well, we're structurally sealing the horizontal.
So it's a little bit bigger?
Yeah, so I don't think we will get enough structural bite with the 1/2-inch glass bite.
Do we still have to be 1/4 inch away from the metal or from the fiberglass? Or it doesn't matter with the fiberglass? Is this still 1/4 inch, right?
Yeah, we still 1/4 inch from edge of glass to bottom of that fiberglass thing.
And we tested that also.
Tested it already, correct.
And then there was a really cool picture down here. So since we have this raceway in the captured sill, that we consider making the sill gasket work on captured and invisible. But I think we're happier with the performance of the captured gasket. So I don't think we were moving to that invisible gasket on the captured sill. There's a few little problems with that. So.
So it's interesting, you have the dark background. I published that comment on the light background so you can actually see the picture better. So I didn't realize that it would do that if your default was set to dark.
That's funny.
I thought there was something wrong with my video.
That's funny. And then our verticals were fairly typical. The thing is we are using a 2-piece vertical even at the jam. So that would sort of make it a little easier to use this part everywhere and not have all those access holes and all those plugs. So this was sort of what we were looking at. It also helps with sunshade brackets and other parts that, you know, can't be typical if we have a captured jam volume. And then again, we would change the aluminum extrusions and not the pultrusion parts.
On this detail too, I think about moving that cock joint back. I think somebody else traced it in there, but.
To move it back to here?
To pick up the pultrusion part.
And now it needs to move all the way back to the pultrusion, right? If that's the water line.
Yeah.
Yeah.
Agreed.
Yeah, so then the end dams now was next question would be exposed, yeah.
Yeah, and end dams need to be covered.
Well, you could just pull that back, right?
Wasn't that the problem we had at Britannia Cove? Let's take a look at that.
I think the problem we had at Britannia Cove is we didn't run the end dam into the sealant. The end dam stopped short, but the sealant line moved out the 2 inches of the extended cover, and so there was a hole right there, right?
Yeah, I knew it had to do with sealant and an end dam.
Yeah.
Like every mock-up, right?
And then somebody was asking, hey, you know, could we just extrude this part? So that could work good for a bunch of things. So we'll take a look at that. Should we move the raceway anymore? Could we update the die? Are we talking about the bayonet raceway?
No, for that little clip in the back that we've now say never required
the,
anymore.
Anti-buckling raceway.
Yeah, I don't know. Kendall, your thoughts on that?
I don't have any definitive thoughts today.
Okay.
Seems like it could be eliminated, but I don't know if it would ever be required or not. Our engineers have told us no, but I don't know. I'd have to probably talk to Seattle to see if they use it for anything other than that maybe we just haven't run into yet.
I think for now, Kendall, we'll just leave it in there just in case.
Yeah, but it's worth looking at. It's worth considering and seeing what's going on. It's just one more heartache for the extruders, like Heather says. Any of those little small legs that you got on a big thick part just causes for grief. I don't think they're having any issues yet, but.
And if that type of design is in the system, that always comes up as a question when we get to fabs. Do we need to do something here?
Yeah. Okay. We missed our access holes. Gasket number appears to be recessed from face of glass. Is that intentional?
So there, I've actually created a new gasket to bring it flush.
Okay, nice. And then, yeah, so door jambs, we've got to sort of do a little work at that. So we'll look at those in the next round. Yeah, the P-well parts, we'll have we had those tested from Dow. Everything seemed good.
So kind of along those lines. So do we have to worry about the finish? Like it's always going to be just one plastic piece, never have to worry about it? Because sometimes these pocket fillers are exposed, sometimes like at doors and stuff. And so when that happens, do we have to go with aluminum extrusions then?
Yeah, that's what we'll have to look at next. I don't want to have different finishes on this part. So.
Okay.
Yeah, I think, Steve, we talked about just keep using the aluminum piece for the door jambs and stuff like that, and use the protrusion at a true jam condition to get the thermal properties of that.
Yeah, because the door is not really thermally broken anyway, so.
Yeah.
And then our corners, we changed this part so we could have a physical attachment because we had problems with that in the past. This is the only sort of isobar piece that we're maintaining, so we try to keep this in black, so we're not having to make strut after painting. But that might be an architect's choice on some jobs.
Western will have an issue with strutting that.
Okay.
Because there's no way for the rollers to support it going through the machine.
Kendall?
Yes.
Kendall, I just feel you have a lot of metal put in front right here. Did you hear me?
In this corner?
Yeah, like here, I circled here, basically, but I don't know.
She's on the inside corner. I think she's on the inside corner, Steve, I think.
Yeah. Well, yeah, inside corner, and also, I don't know, I'm just full part, I just by my eyeball it. I feel you put a lot of metal in front. Is that because you want this shape, or because the structure or window is required? It seems a lot more metal than I expected. I know corner does not affect the building that much. I want to point out, maybe we should thinking sometimes we don't have to make this line straight, because this is maybe not affect anything. Oh, yeah, this water line right here. You can do whatever you want, and this one, you don't have to make it straight. I mean, just open mind when you design dies. Sure. We are not true customer critical company. We doing standard systems. So a little bit of saving, it will be affect a dramatic percentage. You know what I'm saying? So when we design that, we need to be very, very cautious about it.
Okay.
Yeah, it'd be good to see sort of the sunshade bracket design there too, right?
Right.
Could affect that design slightly too.
I got a question. For the head member of stack joint at corners, are we maintaining the same approach of adding the small piece at the top, or are we going to be coping here?
For the bridge at the corners, it's going to be 2 pieces, half the width, right? Cut, mitered, and then assembled together. So it's still going to have a bridge, but it's going to have to be fabricated, right, from 2 different parts. Okay, is that what you're asking, Eduardo, about the bridge?
Yes, that's it. Yeah.
Yep, there you go.
Thank you.
Yeah, we'll have to flush out all the individual intricacies of it, but that's the intent, is it'll have a bridge as well.
I had a lot of questions about how does all of the head trim work at the corners and how does it keep clear for installation. I did those sketches of how the current version works. Maybe it's a similar method, but I don't know if we've looked at that in depth yet.
Yeah, I think a little study on the head trims is in order for sure.
Steve, do we have a mock-up for the corners already?
No.
No, we don't have yet.
I think we probably will run into some issues on the female outside corner, the front fasteners right there. Because, you know, like we always do is like all these fasteners will be close to an 1/8 setback, so, you know, offset to the back.
Mm-hmm.
Right there, you know, we might have a little issues right at this area right here, if you can see it, my annotation.
Yeah.
Yeah, it's close to, you know, sometimes we will have to move like 0.15 further back to, you know, to allow the fasteners to go in and do not suck the horizontal past the glass pocket, the glass pocket line on the vertical. Then we might have a little issue. We might have to hit the male leg over there. Or cut it too deep into the gasket.
Are you referring, Tony, to the difficulty the shop has in drilling that hole where it needs to be?
Yes.
I thought we had that all worked out. I thought the last I heard that the shop had figured out how to do it.
Well, we offset your hole. We offset, you know, the pictures right here. You know, whatever you show that picture, we offset in to the interior. You know, like close to 1/16 or 1.5, depends on you know what kind of corner mullion you have. So whatever it shows right here, the hole is not exactly at that V groove. It will be moved toward into the interior for the outside corner. For the inside corner, it will move forward into the glass pocket.
So the screw is not centered on that V groove, so it doesn't go into the raceway of the horizontal?
Yep, we lever center it into that V groove.
So we're still drilling those holes by hand from the flat side?
Flat side? What do you mean by the flat side?
From the outside, not from the inside, right? So we're not using the V groove as a guide. We're drilling them by hand, going perpendicular, and then they squirrel the drill bit around.
No, the machines come in like this.
But the bit's still bending.
But the bit, yeah, like that, with the drill bit like that, offset with your V groove.
But it still bends as it tries to go in.
No, it doesn't bend that much because we the first couple cut we went small to just allow the mill bit, the fluid cut into it before it went straight in. Because if we go cut it deep at the first cut, the mill bit will walk, this way. But if we do a little, kind of like shaving cut on the first 2 steps before we go in, and never walk again.
Oh yeah, I thought you were talking about filling this in right here.
Tony, I have I have, I'm thinking this way because I haven't discussed this one with some project. I think this is some question I want to address for the future, because we do a lot of trapezoid shape, but the detail will be used standard. But I've been in contact with some takeoff group for this one. I know some people, they pay attention on this one. They switch this fastener from hex head to flat head. So Tony, if you do flat head, you give you about 28.7 degrees flexible. Do you know what I mean?
Yeah, I understand.
Because if
the flat head will work too, but
yeah.
the thing is, realistically, is the thread is the one that pulling the material forward right here.
I see. Got it.
Yeah, that's the,
Got it.
and then
yeah.
on the opposite way, it pulling into it, and we've been testing it in Mike Bruno and I get our hands on it, and Dylan, we get our hands on it so many times. That's why we find out, we have to offset them. And even
I see. I
was a part of it too,
I
a
can
long time
help
ago.
with this. Yeah, I can help with this for improvement. I have a couple ways to do this one in the past. But another thing, Tony, I noticed that you mentioned some unit for dimension. You said 0.25 nanometer, correct?
Excuse me?
You mentioned at the beginning, you said some off like 0.25 nanometer. So I just curious, what's the unit of your machine? Is it use nanometer or imperial? Because I always struggle. Huh?
Go ahead.
I mean, I usually use nanometer for the die design, but I have two sets of dimensions. Because nanometer is more precisely special for fabrication. When you go down to smaller scale, I think that's why I tried proposal. We should really do the die, doing die with nanometer, but you always can set up two set of dimensions.
Yeah, we can.
That will make it much easier.
I think we can have a different discussions on that one later, on itself,
yeah,
and during this meeting right now, Yeah.
Sorry.
No, it's okay. But the hard thing with that is everybody in the fab team is using imperial units. So if you make the dies in millimeters, you're gonna have weird millimeters because they're really gonna be in English units. So
exactly. So during the programming, we do millimeters. We do the fact.
I love millimeters.
Yeah, we do millimeters during the programming. We do whatever it comes out
from the behind the word.
Yeah. So anyway, yeah, that's
American
a different
behind the word.
yeah, that's different discussions.
Decimals are more precise than both. So why don't we just do it that way?
Yeah.
When the first articles go out, we could experiment on Tony's concerns.
Yep, to check that part for sure. But we might want to kind of look
Sorry, no more distraction.
Might want to look at it a little ahead of the first article, because it sounds like maybe that raceway isn't in the right spot anyway.
Yeah, if the part pulls a consistent dimension because of that miter, then if we can determine what that is, maybe we could offset that screw port in the vertical mullion, that die line, by the amount that we're expecting that part to pull to align those glass pockets. And that's been a consistent problem on the shop floor with any kind of a miter throughout the building of units. We've never approached it in the way that we designed the dies. It's never been addressed at that level.
Yeah, that'd be good to kind of nail that down.
Hey, Heather, you said Western can't do that corner die like that?
No, they can't. They have to, so they have rollers supporting the two shapes and putting a lot of pressure, and there's not a flat, stable surface for that to go through on when it's going through the crimpers.
So this leg's in the way, right?
Yeah, we should talk to them, Heather, because I mean, our knife blade.
I have.
sunshade, well, our knife blade sunshade bracket's only got 1/4 of an inch on the front. So I don't know what the difference between that and that point of the V.
What do you mean, knife blade sunshade bracket?
Well, the flat plate sunshade bracket, or the flat little glass trim, right? It's just got 2 thin little things. So I don't know if you know, in talking with them, what the difference between if they just turn that part 45 degrees and let that point run on the bottom surface.
These are some of the things I think we'll
yeah,
get into.
yeah, we'll work them out. Yeah, we'll definitely review it with them and see.
Yeah. And get that good information so we know how to make the designs right? So.
Yeah.
Yeah, so we still will have Pony Tubes as of today, if you were wondering. And we do need to still work out the sunshade bracket attachments on these. So.
Yeah.
And that's sheet 8 of 8.
Yeah, thanks for all these comments here. It's really good.
No, it helps a lot.
Yeah.
And there's some great things in here. So going forward, what we'll do is we'll clean up what we've done. I think we've already kind of done some of the cleanup already, but address some of the things we're all talking about and kind of look at that. It sounds like there might be an interesting discussion on gaskets. Sounds like this corner and the screws would be an interesting one too. And then, you know, we're going to go out and get some feedback from the vendors, the engineers, some of our customers, some of our consultants. So we'll probably have another, you know, good round with a bunch of other people that are having a bunch of different comments for us. And that's what we're looking for, is just, you know, get as wide a selection of input as we can so we can make the best choices that we can. So. And that's all we had today.
Bye, everyone.
Thank you.
Thank you.
Thanks, everybody.
Thank you.
Thanks, guys.
Thanks,
Steve.
Hey, Steve.
Yes.
I forgot one thing. The bridges, did we do them out of the head material or we did them out of the seal track material?
I think when we did them out of the sill track material, but we're probably going to push something more specific.
So you think we're going to do it out of the head material?
Yeah, maybe, or maybe we make its own die. I'm not sure which way yet.
On Lumen,
we're making a new die.
Yeah, when we had that articulated mullion that we needed that head to do a weird thing, it works so much better to just have a die that's designed to do what you want it to do than to have to chop legs and figure out, because it's got those little things that like a tab that comes down on it to lock it in and all of that.
Mm-hmm. Yeah, if we have to modify the head extrusion, it's a lot of work too. Yeah.
No, we'll make a new die like what we did on Lumen.
Okay.
So Steve, one of the things that we might think about is, as even after these are cleaned up for this initial round, is running them through takeoffs, letting us build some what would be producible units, because we come up with so many of the little tiny design things, like which part should be flat in order to connect together. We work out, we have those discussions about which parts need to notch in certain ways to, you know, interact with each other properly. So I think that would be a good next iteration, just to get the takeoff team in there and build some samples of these to provide an additional level of feedback for the design.
Yeah, that's a good idea. Because there are a lot of little things that you'll see before we get too far along, for sure.
So Steve, when we design a new system over here, can you go to the vertical details? Do we look into the notches at the back leg of the female? At the male? Do we just keeping the chicken head at the same spot with the? Did we move it forward because like we always have a concern is if the dice is not straight, that leg or the male leg at the back will become either notch out or become a piece of foil paper.
Yeah.
And
we did not move the chicken head.
Okay. So it's like we explained to you, like what we did is right now is we move that slot like 30 seconds forward right here, aligning in the inner wall. That's what we've been doing the last few years, you know, because we have experienced this leg is gone sometimes, completely gone. Yeah, or just a piece of aluminum foil paper only.
Yeah.
Yeah, we could move that back leg so that you don't have to.
Yeah, so
doesn't interfere with that little doohickey there, the male
and
leg.
on the other hand, if you go to the seal detail, if you move it forward, your whole location, this particular whole location will get so close to that slot.
That's the thing we need to.
Yeah.
If you do that, we need to change the back screw boss on the horizontals.
Yep. It's like, you know, Efren and I talk about we have to have minimum 3/16 gap between there, right? I mean 1/8 gap, right? So that was a concern that we have it already since we have the first W75, but never get addressed it.
Okay, well, this would be a good time for us to take a look at it, even though all these dies are existing.
Yeah, the horizontals are new, so we could make the change now.
Yeah, it would be great if you move it only 1/8, like 4 1/4, for all the back holes. Then we will clear everything. Just like the strip window seal member, we have a 4 1/4 from the glass pocket to the back hole. Because right now everything is typical is a 4 3/8. Yeah. Then we will eliminate all these issues we have.
Okay.
Because if you do that, then the 304 gasket will change also. Because now the things get deeper.
Need a bigger gasket, right, to cover that gap.
Yeah.
Yeah.
Right, guys, got you count.
All right, thank you. Well, that was
Thank you.
Thank you, guys.
Thanks.
You guys.
See ya.